Hello. So today we're going to piggyback on what we started yesterday. This is not going to take very long, so hopefully you can watch this video. I'm going to embed a couple of questions in the video, and then as soon as you're done with it, I'd like you to get started on your assignment. The assignment is due in class today, so you need to turn it in to Mr. Turecki before you leave. Otherwise, I will not take it. Okay, so you must make sure you turn it in today. All right, so yesterday we talked about writing an equation from an exponential function. So we're still going to be talking about that. It's going to be a little more geared towards what is exponential growth and what is exponential decay. Right, so yesterday we spoke about the difference between increasing and decreasing, and for the most part they are very similar, but growth and decay are just a little bit different from increasing versus decreasing. So we've got a reminder. A is my starting point. B is the multiplier. And X is the number term. All right, so the rule we're going to stick with is if B is greater than 1, if B is greater than 1, it is going to be growth. If B is greater than 1, it is exponential growth. If B is between 0 and 1, that will be decay. Okay, so things that grow would be pricing of houses, family tree. When you multiply, something that gets bigger and bigger and bigger. Those are examples of exponential growth. Exponential decay, when you talk about the half-life of a specific mineral, I know if you're in chemistry this year, that is part of it. That's exponential decay. Another thing I like to think about, or I use to help me think about decay, is let's say you die, and when a person dies, their body starts to decay. It starts to decompose. It starts to get smaller and smaller until it whittles down and it's just dust and bones. So decay is when it gets smaller. So I try to think of growth is when it's bigger than 1, decay is less than 1, or between 0 and 1. All right, so we're going to talk about, are these growth or decay? So right here, the one number that I'm focused on is inside the parentheses. Everything that's inside the parentheses, that's what I want to know. 2 is definitely greater than 1, so this is growth. 0.5 is less than 1, so this is decay. Here, greater than 1. 1.3 is greater than 1, so this is growth. All right, so why don't you try D, E, and F? Now, actually, just try D. Okay, I'm going to give you a second. You go ahead and do that one. Now, for E, let's think about this. If it's bigger than 1, that means growth. Less than 1 is decay. So inside these parentheses, if I'm starting at 1 and I add, it's definitely going to be bigger than 1. So this plus sign means it's growth. Now 1 plus 0.025 would be 1.025. But again, it's bigger than 1, so this would be growth. Now here I'm starting with 1 and I'm subtracting. Now 1 minus 0.4 is obviously 0.6, but you might not always see it as 0.6. You might see something that looks like this, especially when we get into finances. So this number, it is less than 1. Because of the minus sign, this is decay. All right, so number 2, it says given the equation 8,000 times 0.97 to the power of 6. What is the rate of decay. All right, now what we're going to do is I'm going to focus on this number, 0.97. Now, I know I'm going to compare it to this right here. It is less than 1, but how much less than 1? I want to know 1 minus what equals 0.97. Okay, 1 minus what equals 0.97. And I can do that by saying 1 minus 0.97, and that equals 0.03. Okay, so 0.03 is what I subtracted by. Now, you notice all of these are in percentages, okay? Rates are going to be in percentage. So in order to take a decimal to a percent, what we're going to do is we're going to multiply by 100. When you multiply by 100, you move your decimal 2 times, which means this would be 3%. So my answer is C. Okay, now we know the rate of decay, 3%. It's losing 3% each year or each day or whatever this is going to be done by. And so I want to know what is the initial amount. So I'm going to go back up here to my starting point. Here's my starting point. This starting point, that's what I'm looking for. Initial starting point, y-intercept. That's the A. So what is A? Right here, 8,500. All right, next, given the equation 8,500 times 0.97, which number was the time period? This time period, that is my term. That's the number term. 8,500, definitely not a time period. 0.97, not a time period. The time period is going to be this 6 right here. So, number 5, it says the rate of growth of cells doubles every hour. What could model the number of cells if there were 4 cells initially? All right, so doubling is going to be important, and 4 cells initially. So I need an equation. I need an A and a B. A is my starting point or initial point, and that is going to be the 4. Now, I want to know, what am I multiplying by every time? What do I multiply to get from one to the other? Now, it says it's going to double every hour, which means doubling is times 2. So B is going to be 2. So if I have A times B to the X, this time it's saying hour, so I'm going to use an H, A times B, to the H. Now, A is 4, and B is 2. Okay, so you should be able to find your answer. All right, number 6, it says, since January 1980, the population of the city of Brownsville has grown by this equation, where X is the number of years since 1980. Now, first off, what does 720,500 represent? Well, it's in this A spot. It's in the initial or the starting point, but where does it start in this situation? Well, we started in what year? 1980. So this represents the population in 1980. Now, what is the growth rate or decay rate? Okay, now I notice this is bigger than 1. This is bigger than 1, so it's definitely growth, not decay. So I want to know 1 plus what equals 1.022. So in my calculator, 1.022 minus 1 is 0.022. Now, I want the rate, which means I need to multiply that by 100. So I'm going to bring my decimal over 2 times. That would be 2.2%. Now it says, what would the population be in 2000 if the growth continues at the same rate? Now I need to know when 2000 is. Okay, if I start in 1980 and I go to 2000, how many years is that? I mean, I can just use my calculator. 2000 minus 1980, and that would be 20 years. All right, so I'm going to go to y equals, and I'm going to input my equation. It says 720,500. Okay, so I'm going to type that in, 720,500, parentheses, 1.022 to the power of x. All right, so this population is growing by 2.2% every year. So I want to know what happened in year 2000. So I'm going to go in my table and I want to know where it is in the year 2000, which is 20 years after. So we're going to go to 20 years. All right, it says 1.1 e to the 6th, but if I hover over it, now I can actually see the number. It says 1,113,401. 1,113,401. Whoops. So I'm going to write that down. 1,114,000. Oh, let's go back. 113,401. And that's it. So this last part, we did this yesterday. So all you're going to do is plug these numbers into stat edit, calculate, and find the regression. So I'm going to do one of these examples with you, and then I'm just going to leave you the rest of class to finish it on your own, because I don't think you need this much practice on it. All right, so we're going to go stat edit and type in our numbers. -7, -3, -2, -1, and then 81920. Oops, doesn't go there. 81920, 320, 80, and 20. All right, so I've typed it in. Stat calc. Remember, we're going to do number 0 because that's exponential, and go down and calculate. I've got my equation. A is 5, B is 0.25, so y equals 5 times 0.25 to the power of x. Now, B is 0.25. I want to know, is this growth or decay? Well, B is less than 1, so it is decay. Now, a question would be that you might see is, what is the rate of decay? 1 minus what equals 0.25? 1 minus what is 0.25? Well, I know that's 0.75. So it is decreasing by 75% every year. So that's exactly what you're going to be doing, and then you can just go ahead and do that on your homework assignment. So y'all have a great day, and I will see you next week.